Hi everyone, welcome to today's math class. Look at this nested radical equation. Question is root 7 times root 7 under it root 7 times root 7 under it to infinity. Okay, so with this, it means this occurs to infinity. How do we evaluate this? It is easy. Now I'm going to use a simple method, and I will want you to drop your own method you feel best to get or to evaluate this in the comment section. So from here, let's take our solution. All right. So from here, we can just say let the whole of this expression here, let it be, let's take it to be a t. So let's take p rather. Let's take p be equal to the whole of this expression. So we have here 7 times square root of another 7 times the square root of another 7 times the square root of 7 dash. All right, so here we have times here. All right. Okay, so if we are saying let p be equal to everything we have here, even as this goes to infinity. So what we do, this is a square root radical. So we have to eliminate this first one and eliminate the second one, eliminate the third one, eliminate the fourth one, eliminate the fifth one, down to infinity. Doing that, we keep solving till thy kingdom come. Because infinity does not have end. Okay, so what we do, since we are saying p is equal to the whole of this, and we have to eliminate this first radical, so we take the square of both sides. So we equally take the square of this. And so what happened? These will go with this. And so we're going to have our p squared is equal to, we're going to have 7 times the square root of our 7 times the square root of our 7 times the square root of our 7 to infinity. Again, this will lead to infinity. Right? Good. Now, let's take a look at this. Here we said let p be equal to this expression which leads to infinity. And we are having this same expression which leads to infinity. So we can put this in bracket, This is same thing as this, aside this square, right? Okay. So if this is same thing as this that leads to infinity, and we said p is equal to b, therefore we can say that what we have here is equivalent to our p here. Easy, right? So rewriting this second expression, we're going to have here our p to the power of 2 equal to our 7 times p, which is 7p. Now, this is a quadratic equation, as we all know, okay? Again, we could as well divide through by p, okay? So that we get our p equal to 7. But because this is a quadratic equation, let's move this to this side of the equation. So this is going to give us here our p to the power of 2 minus 7p, this is equal to 0. We can factor out p from here. So we put this in bracket, So bring out p into p squared, we have p left, minus p into 7p, we have 7, close bracket, this is equal to 0. So let's continue on this side here. Okay, here we apply the zero product rule. We take this to 0, we equate this to 0. So we're going to have our case 1, we're going to have our p equal to 0. Now, if this is p1, let's take a look at this expression we have here now. Now, this expression cannot converge into 0. So since it cannot converge into 0, what happened? So p cannot be equal to 0. So what happened? This is rejected. This solution is rejected. So if this is rejected, let's go to our case 2. So we have here case 2. Our case 2, where we have our p minus 7 equal to 0. Send this to this side of the equation. So we're going to have p2 is equal to 7. So the value of our p that actually satisfies this is 7. So 7 is the final answer here. I know some persons or some mathematicians are of the opinion that we use the limit to evaluate this. we use limit to evaluate this, or the GP series to evaluate this. Okay, but that is also fine. But if you have a better way using the GP or using a limit to evaluate this, drop it in the comment section so that Online Maths TV can equally learn from you. Thanks for being there all the time. We love you beyond measure. See you in our next class.